Hi everyone, welcome to this video where we will learn about various best practices for building a scalable and secure multi-VPC AWS network using various AWS services and features. So before we begin, let me give a quick introduction about myself. My name is Aishwarya Sood and I am currently working as a lead coach into the AWS domain, and I am 3x AWS certified, also an AWS Academy accredited educator. You can connect with me on LinkedIn. The profile name is given here. Also, you can scan the QR code to directly view my profile. So let's begin with the topic for today. So in this video, what we are gonna discuss about is first thing about landing zones and the control tower. Then how do we connect multiple VPCs using multiple features and other services, for example VPC sharing and peering. And then we will talk about hybrid connectivity between your on-premises infrastructure and AWS environment using multiple methods like site-to-site VPN connection, direct connect, also transit gateway. So let's begin with the introduction for the today's topic. Most of the AWS customers begin by building resources in a single AWS account, and that represents a management boundary which segments the permissions, cost and the services. But as the customer's organization grows, greater segmentation of services becomes necessary to monitor the cost, control access and provide easier environmental management, because the organization is growing fast. And a multi-account solution solves these issues by providing specific accounts for IT services and users within an organization. But when you should consider creating multiple accounts, you should have some things in your mind. So you consider creating additional AWS accounts if you answer the yes to any of the questions that I'll just ask you right now. So first question can be, does your business require administrative isolation between the workloads? Does your business require limited visibility and discoverability of the workloads? Or does your business require isolation to minimize the blast radius? Or does your business require strong isolation of recovery or auditing the data? So if your answer is yes to any of the questions, you can consider going for multiple account solutions. AWS provides us several tools to manage and control this kind of infrastructure, which is multi-account solution, including the major components, the AWS landing zone and AWS control tower. Both control tower and landing zone help us in setting up and managing secure multi-account AWS environments. So let's talk a little bit more about both the landing zones and control tower. Both AWS landing zones and control tower are the solutions which helps customers quickly set up the secure, scalable and multi-account environments based on the best practices. So let's discuss first about the landing zones. It is a solution that helps customers more quickly set up a secure multi-account AWS environment, which are based on for sure the AWS best practices. With a large number of design choices, setting up a multi-account environment can take a significant amount of time, involve the configuration of multiple accounts and services, and also it requires a deep understanding of AWS services. But it's like the starting point for new development and experimentation, or you can say a starting point for migration of applications and an environment that allows for the iteration and extension over time. So it has two options for creating your landing zone. First, a service-based landing zone using AWS control tower, which we will discuss after this landing zone, and a customized landing zone that you build. So you will understand it better once we discuss about control tower also. That will be helping us in understanding the landing zones even better. So let's discuss what control tower does for us. It is a service that offers the easiest way to set up and also govern a new secure multi-account AWS environment. Also, it establishes a landing zone that is based on the best practices, blueprints, and enables the governance using guardrails that you can use from a pre-packaged list that are already available there. So basically it is for setting up a landing zone, which is nothing but a blueprint for your multi-account environment, and that blueprint will be based on all the best practices. Control tower, I hope you would have understood now that it is nothing but it is helping you to set up the blueprint. Okay, you will get a lot of blueprints there for the multi-account environments. So as we have discussed, landing zone is just a broad term for the scalable, secure and performant multi-account or multi-VPC setup where you deploy your workloads. Now this setup can be built using any tool, and one of them was a control tower. So the solution of the landing zone in this figure includes 4 accounts: the AWS organizations account, which is used to manage the configuration and access to the AWS landing zone managed accounts, and the shared services account, which we are having here, which are used for creating infrastructure shared services such as directory services, and the log archive account, centralized which is doing the centralized logging into S3 buckets, and the security account, which is to be used by a company's security and compliance team to audit or perform emergency security operations in case of an incident in the spoke accounts. So this was one example. There can be many more like this, but as the number of VPCs grows, cross VPC management becomes essential for the operation of the customer's cloud network. And we discussed 3 specific areas in a cross VPC and hybrid connectivity, which includes network connectivity, network security, and the DNS management. So let's dive a little deeper into what is VPC to VPC connectivity, because now we are expanding our infrastructure towards multiple VPCs. So when it comes to having multiple VPCs for your solutions architecture, customers can use 2 different VPC flow patterns to set up multi-VPC environments. One is many-to-many, or another is hub and spoke architecture. In the many-to-many approach, the traffic between each VPC is managed individually between each VPC, whereas in the hub and spoke model, all the inter-VPC traffic flows through a central resource which routes the traffic based on the established rules. And to understand these concepts more and to learn how they are implemented on AWS, we will be discussing topics such as Vpc Peering, Transit Gateway, AWS Private Link, and Amazon Vpc Sharing. So let's first discuss the Vpc Peering. So if you are using a multi-VPC architecture pattern, you will require your VPCs to communicate to each other, because you may need to transfer the data between 2 or more VPCs. That's quite obvious. But one of the ways to make this communication possible is through Vpc Peering. So let's discuss what exactly is this Vpc Peering. It is the simplest way to connect 2 VPCs because in this setup, a connection enables full bidirectional connectivity between the VPCs that you are peering. So this peering connection is used to route the traffic between the VPCs, and VPCs across accounts and across regions can also be peered together. Also, Vpc peering is a point-to-point connectivity, and it doesn't support transitive peering. For example, if you have a Vpc peering connection between VPC A and VPC B, and between VPC A and VPC C. Now, an instance in VPC B cannot transit through VPC A to reach VPC C. Basically, in short, it means that transitive peering says if A is connected to B, B is connected to C, this means A is also connected to C. But something like this is not available and not allowed in the Vpc peering. Whatsoever VPC needs to be connected to each other, it has to have a direct one-to-one connection between each other. And there is no early infrastructure fee. It's just the cost for the traffic that is traveling over the connection that you have established. And the VPCs participating in the peering connection should not have the overlapping CIDR blocks. Both of them, all of them, whatsoever it is here, they should be having different CIDR blocks. And there's no internet gateway or virtual gateway required, because the traffic will stay on the AWS backbone network, and the communication will happen through the private IP addresses. And It's a point-to-point connection. At scale, when you have tens of hundreds of VPCs, interconnecting them with peering results in a mesh of hundreds, thousands of peering connections, which are difficult to manage and scale. So I'll show you what's the solution to that as well. VPC peering is, I think, best used when resources in one VPC must communicate with resources in another VPC. The environment of both the VPCs is controlled and secured, and the number of VPCs to be connected is less than 10. This is to allow for the individual management of each connection. And VPC peering offers the lowest overall cost when compared to other options for inter-VPC connectivity that we will be learning in the upcoming slides. So in the diagram that you can see on the slide here the VPCs dev and test are paired, which doesn't mean that prod VPC can talk to dev. By default, VPC peering does not allow prod to connect to dev unless and until there are explicit VPC peering connections between them. Therefore, you control which VPCs can talk to each other through the VPC peering, because transitive peering here is not supported at all. So let's get to a demo to understand how to implement this VPC peering actually in the AWS console. So before we go to the AWS console to actually see the demo, I will like to explain the architecture for the demo that I am going to do, because it's better to understand since it will be containing a lot of components. So what I did first, I have already created a few resources to save some time and to show you the actual thing that we are gonna do here. What I have done in my AWS account is I created one VPC which I named as first VPC, and then I created a second VPC. Okay, for the first VPC I gave this CIDR range 10.100.0.0/16, and for the second VPC I have given 10.200.0.0/16. Now why I gave different IP ranges? Because since I am going to establish a peering connection between them, their IPs should be not overlapping. If I give 10.100 here also, 10.100 here also, then they won't be able to establish a peering connection between them, because after peering it becomes a same network. So within a network these IPs cannot be the same, but if you are not planning to peer them, then they can have the same CIDR blocks. So after creating first VPC, I also created an internet gateway to be attached to my first VPC. Then I created one subnet in my first VPC, and then I created a route table for this public subnet where the local entry was there automatically, and along with that I added the entry for the internet gateway. And then I attached that route table to the public subnet that I created here. After this I created another subnet in my first VPC which I named as private subnet, and for that then I created a route table where only the local entry was there, and I attached it to my private subnet. After this, after our first VPC was set up, I created an EC2 instance within my public subnet, where in the security groups I just allowed the SSH to be done only from my local IP address. Then I created one more EC2 instance, but this time in the private subnet of my first VPC, where I allowed the SSH to be done only from the CIDR range of my public subnet, that is 10.100.0.0/24. okay, because the requirement is that the internet traffic can come directly to the public subnet's EC2 instance, and there should be no connectivity from the internet to the private subnet. So here the SSH can only be done when we are connected to the public EC2 instance, and from within that we want to connect to the private EC2 instance. So this I will show you on the console as well, that how to do it. So here my first VPC setup was done. After that what I did, I created another VPC with the name of second VPC which already was there. Now at this step I created a private subnet in my second VPC. I created a subnet and I created a route table where I left only the local entry to be there, no internet gateway entry, okay, because for this VPC I didn't create a IGW as well. So since there was no IGW, there no entry in this, because I wanted this to be a private subnet. Then I attached that route table to my private subnet. After this I launched an EC2 instance in my private subnet of the second VPC. Now here in the security group of this EC2, what I allowed, the SSH only from this IP range, that is 10.100.1.0/24, and the all ICMP v4 traffic from this same IP range, that is 10.100.1.0/24, so that only the traffic, the SSH or pings that are coming from the private EC2 of my private subnet of my first VPC, only that will be allowed into the private subnet of my second VPC. So that was done, the entire infrastructure setup was done. Now I will connect to this first EC2 instance and show you that how we can reach towards our third EC2 instance from within the first EC2 instance itself. For the first EC2 instance, it is able to be connected from the internet because it has an internet gateway entry in the route table of this subnet. So it can receive the internet traffic. Now without any further delay, we will go ahead and connect to our first EC2 instance. So let me show you the instances that I have. These are the 3 EC2 instances that I have: EC2 private for the first VPC and EC2 public for the first VPC, which are these 2 instances. And then third instance I have EC2 private for the second VPC. So let's connect to our EC2 public first VPC. From the PuTTY we will establish a connection. Let's copy this public IP address and paste it here, and connection, I'll keep the seconds at least 50 so that it doesn't time out, and then we will add the key, the private key. So I have this key already with me and I'll open it. So let me connect to my EC2 instance. Yes, here I am connected to my EC2 instance. Now this means the connection to the first EC2 instance is successfully done. Now from my first EC2, I want to enter into my private EC2, which is belonging to the private subnet of the same VPC. So what I'll do a SSH into my private EC2 instance. Let's quickly do that. SSH EC2-user at private IP of our private EC2 instance, which is this one, EC2 private first VPC. So I'll copy this and paste it here, enter. Now why I am not able to connect to my private EC2 instance here? Because there is no private key that I have given here. So before I connect to my private EC2 instance, I have to give the key also, because of course it needs the SSH key to connect to the second instance. So what we will do, I have the key already with me, the PEM file that I have. I'll open it in the notepad. I'll copy the entire content of this, and then in this I'll do vim ica.pem. I'm creating a file. Here I have pasted the content which I just copied from the notepad. Now we will do shift ZZ 2 times, and then we will just confirm if the content is there in the ica.pem. Yes, it is there. Now we will change the permissions also so that this key can be accessed by our first EC2. So it is done. Now let me try connecting to my second EC2 instance. So I'll just add this here. Yes, now you can see I am able to establish the connection to my second EC2 instance that is located in the private subnet of my first VPC. And how did I connect from this? First I logged into my first EC2 instance that is there in the public subnet. Then from within this I have connected through SSH to my second EC2 instance, which is in the private subnet of the same VPC. Now this connection whole is done. Now the third requirement is that I want to SSH into the next EC2 that is belonging to a private subnet but for a second VPC. It's not there in the same VPC. Now my security group rules are correct. I have added all the appropriate rules, and this is the security group rules allow this SSH or ping from this EC2 instance. So let me try if I can connect to my third EC2 instance which belongs to different VPC from this EC2 or not. So what I'll do, SSH, and let's take the private IP address of our private second VPC. Let's take this. So here I go, I'll paste this and enter. So you can see it is not responding anything because we can't connect to our third EC2 instance because it belongs to second VPC, and till now there is no connection between our first VPC and the second VPC. Although we have two VPCs, we have all the resources ready, but they are not peered yet. So I'll also try to send a ping request to the same IP address to, let's see if I can connect over the ping. No, here also I'm not getting any response. So I'll just go back and peer my VPCs because I'm not able to connect from this EC2 to this EC2. So I'll establish a peering connection now. So for that we will go to the VPC and we'll establish a peering connection between both of our first VPC and the second VPC. So here I'm into the VPC console. What I'll do, I'll show you the VPCs that I have created. So we have first VPC, second VPC and the default VPC right now, and we will create a peering connection now. Let me find where is the peering. One second. So it's here. We will go to the peering connection and we will create a peering connection. Right now there is none existing. I will say peering is just I'm giving the peering name, and first VPC I have to select from which the request should be sent, which is our first VPC, because this VPC needs to be paired with the second VPC. So this is a requester VPC. Another VPC is in my account or another account. It is also in my account. Then is it in the same region or in different region? It is in the same region. Who is the acceptor VPC? It is my second VPC, and then I'll go ahead and create the peering connection. So here I go, the peering connection has been created, but you can see here the pending acceptance by another VPC. So here I will go to the back to the peering connection, and it is still showing that the acceptance is pending. Request has been sent, but who will accept the request, that also we have to do. So we will select this and we will see if there is any request. Once there is any request, it will notify you and it will enable the option of accept and reject the request. But if there is no request, then nothing like this will be enabled. So right now I'll say accept the request. It will show me all the details for what request is there, and I will accept this request. Now the peering connection has been established. The peering also is done. Okay, these two VPCs are paired, but it's not ended here, because let me show you, if I still I am not able to connect to my second VPC. This is because we need to add the appropriate route table entries as well along with the peering connection establishment. So we will go ahead and add the appropriate route table entries as well. After this it will be able to connect. Okay, so we will go to the route tables and edit the route tables of both subnets, the private subnet of first VPC and the private subnet of second VPC. So in the route table of first VPC's private subnet, what I need to add, let me show you the routes that we need to add. The route that we need to add, first we will say peering connection is something that we want to add, and it is showing this is, and here we have to give the CIDR range of our second VPC. So the CIDR range of second VPC is this. Okay, so I'll add it, or we can directly add the CIDR range of this itself. One second, we can directly add the CIDR range of this subnet as well to make it even narrow. And let's go ahead, we will just add this. So this is correct, and we will save the changes. Now let me check if it is attached to my subnet or not. Yes, it is attached as well. I'll go back to the route tables and will edit the routes of the second subnet. Here also the route needs to be edited. So I'll add the route peering connection from this, and from here I'll add the CIDR of my this subnet, which is 10.100.1.0/24. So let's go ahead. The routes have been added. We will save the changes now. Now our architecture setup is completely done. The peering connection has been added. The routes have been edited. So now hopefully we will be able to SSH and ping from our private EC2 of first VPC to the private EC2 of second VPC. So let me check that. So you can see I did a ping from my second private EC2 instance to the third private EC2 instance, and you can see I'm getting the responses here. This is because we have added all the appropriate routes, we have established the proper peering connection, and everything has been done. Now this connection is established from my this EC2 to this EC2. Okay, so this is how I have connected 2 of my VPCs, but this was just for 2 VPCs. There can be multiple VPCs where you are establishing the peering connection. The process will remain the same. I just showed you for the 2 VPCs. So I'll stop it here, and you can see all the packets that transmitted, for them the responses were received. There was 0% packet loss, and this depicts that we have a 2 VPCs setup which are connected to each other. But let's now go back onto the slides, and let me tell you one thing. The another way for connecting our VPCs when there are more VPCs. The another option for making the communication possible between multiple VPCs is to use a transit gateway, because for few VPCs a peering connection will be fine, but what if there are hundreds of VPCs? That will create a complete mess if you are using the VPC peering in that case, because in that case you have to establish a one-to-one peering connection. So it will become something like this, a messy peering connection. And if you need the detailed steps of each and every component creation for the VPC peering, you can reach out to me on LinkedIn after this session. So I was telling about the transit gateway. Here you can see it will create a mess if the number of VPCs are more. So what we can do? We have transit gateway. It provides a hub and spoke design for connecting VPCs and on-premises networks as a fully managed service without requiring you to provision any virtual appliances. So no VPN overlay is required, and AWS manages a high availability and scalability in this. Because transit gateway allows you to connect up to 5,000 VPCs and on-premises environments with a single transit gateway, and you can attach all your hybrid connectivity, which is VPN or maybe the direct connect connections, to a single transit gateway, consolidating and controlling your organization's entire AWS routing configuration in one place. And you can check out the figure for the same point. Then transit gateway controls how the traffic is routed among all the connected spoke networks. These are the spoke networks. This is a hub, using the route tables. So route tables play a major role, whether we are talking about peering connection or we are talking about transit gateway, they play a major role. And this hub and spoke model simplifies the management and also reduces the operational cost, because VPCs only connect to the transit gateway to gain access to the connected networks. They don't need to be connected to each other individually. So next thing that we have here in the concept is AWS Private Link. So here let's discuss about private link. Here let's say customers may want to privately expose a service or an application that is residing in one VPC, that is a service provider, to other consumer VPCs within an AWS region in a way that only consumer VPCs initiate the connections to the service provider VPC. An example of this can be the ability of your private applications to access the service provider APIs. And how do we use this? To use the AWS Private Link, we have to create a network load balancer for our application in our VPC, and then create a VPC endpoint service configuration that is pointing to that load balancer. and a service consumer then creates an interface endpoint to your service. This creates an elastic network interface in your subnet with the private IP address that serves as an entry point for the traffic that is destined to the service. The consumer and service doesn't require to be in the same VPC, and if the VPC is different, the consumer and service provider VPCs can have even overlapping IP address ranges. And in addition to creating the interface VPC endpoint to access services in another VPCs, you can create interface VPC endpoints to privately access supported AWS services through private link as shown in the figure also. So basically you just have to have the requirement, like let's say the services that are within the VPC and the service that are there outside of the VPC in the same. So you want to establish a connection between those two services, one within the VPC and one outside the VPC. For example, between EC2 and S3, where the normal connections happen over the internet. So your requirement is that from EC2 to S3, you want to connect privately, not over the internet. In that case also, you can use this VPC interface endpoints. And your architecture will contain a mix of these technologies in order to fulfill different use cases, and all of these services can be combined and operated with each other. For example, AWS Private Link handling API style client server connectivity, and Vpc Peering for handling direct connectivity requirements, where the placement groups may still be desired within the region, or maybe the inter-region connectivity is also needed, and the transit gateway to simplify the connectivity of VPCs at scale, as well as edge consolidation for your hybrid connectivity. But VPC peering and private link serve two different purposes. Peering enables you to connect two VPC in same way you would connect two local networks together and remote networks using VPN. But VPC peering also allows network traffic on one VPC to second VPC. For example, you can SSH from an instance in VPC A into instance in VPC B, which is just now we have seen in the demo. Private link is used to expose individual services of yours in VPC A to the VPC B, but this doesn't allow for the free flow of network traffic from VPC A to VPC B. Only some individual specific services you can expose to some other VPC. So let's talk about another amazing feature, that is Amazon VPC Sharing. So this enables customers to share the subnets with other AWS accounts in the same organization when you are using AWS organizations. It will enable multiple AWS accounts to create their application resources, which can be EC2 instances, which can be RDS instances, or any other resources in the same VPC. So in this model, the account that owns the VPC, which is the owner, shares one or more subnets with other accounts that will be the participants that belong to the same organization in the AWS organizations. So all of them are the member accounts that belong to the organization. It's just that one account is creating the VPC, the owner account, and is sharing that other member accounts can also work on the same VPC. And after a subnet is shared, the participants that are there, they can view, they can create, modify, and also delete their application resources in the subnets that are shared with them. But participants cannot view, modify, or delete the resources that belong to other participants or the other VPC owner. So VPC sharing, this kind of thing has several benefits. For example, separation of duties. Here the centralized control of VPC structure is there for the centralized control for the routing and for the IP address allocation as well. The ownership is there. Application owners continue to own the resources, accounts, and security groups. It's just that there are more participants added who are working on the same resources. Also, this VPC sharing enables you to decouple the accounts and networks. You will have fewer, larger, centrally managed VPCs, and highly interconnected applications automatically benefit from this kind of approach. You just create one VPC. There are multiple people who are working, multiple AWS accounts who are working on the same VPC. Apart from this, let's talk about the hybrid connectivity now. So the hybrid connectivity solutions of AWS link your on-premises and the AWS cloud networks to support a wide range of hybrid architectures and the use cases. We have two options for establishing the hybrid connectivity between AWS environment and on-prem environment. One is one-to-one connectivity, where in this setup a VPN connection or a direct connect is created for every VPC, and this is accomplished by leveraging the virtual private gateway. Okay, so those things we will be discussing in the upcoming slides that we have. Then this option is great for small number of VPCs, but as a customer scales their VPCs, managing hybrid connectivity per VPC can become difficult. So another thing, as we have seen, is the edge consolidation, because in this setup what happens is customer consolidate hybrid IT connectivity for multiple VPCs at a single endpoint, and all the VPCs share these hybrid connections. And who lets us accomplish this thing? Obviously this is accomplished by the transit gateway. So let's discuss about both the options that we have for hybrid connectivity, the site-to-site VPN and the direct connect. Site-to-site VPN is the first option for establishing a hybrid communication. Okay, so let's discuss. By default, instances that you launch into a VPC cannot communicate with your remote network. To connect your VPC to your remote network, that is you just have to create a VPN connection. Okay, this is just one option. Another option will be direct connect. First thing that you will have to create for this kind of setup is a virtual gateway device. Okay, it is also known as virtual private gateway, and attach it to your VPC. So when we are talking about a VPN connection, we are talking about VPN concentrators as well. One VPN concentrator at the AWS side of connection, one VPN concentrator at the your side of connection. So the VPN concentrator here is virtual private gateway. The VPN concentrator at your side is the customer gateway. Then you define the configuration of the VPN device or the customer gateway, and the customer gateway is not a device but an AWS resource that will provide the information to AWS about your VPN device. Then you create a custom route table to point the corporate data center traffic to the VPN. Okay, so here how the routable rules will be looking like. This is a CIDR block of your on-prem network, and here will be the VGW ID, and you will also have to update the security group rules appropriately in order to allow the traffic between both the environments. Then establish an AWS site-to-site VPN connection to link the two systems together, and also you configure the routing to pass the traffic through the connection through the route tables, through the appropriate NACLs, through the appropriate security group rules. Now VPN establishes a connection over the internet. Although it is secure, it is encrypted, but still it is establishing the connection over the internet. What if you have a requirement that you want the hybrid communication that you are having here, it should not involve the internet at all? In that case, you can go for something known as direct connect, which is also known as, in short, we can call it as DX as well. Because one of the challenges of network communication through internet is the network performance. Performance can be negatively affected if your data center is located far away from your AWS region. For such situations, AWS has this offering, that is AWS Direct Connect, which enables you to establish a dedicated private network connection between your network and one of the DX locations. So this private connection can reduce your network cost, increase the bandwidth, throughput, and provide a more consistent network experience than the internet based connections. So how this connections exactly happens is that from your location, that is your on-premises data center, you will be having a customer gateway, of course. From your location to the DX location, to the nearest DX location, you will be having a dedicated connection. One end of the cable will be connected to the router at your location. Another end of the cable will be connected to a router at the DX location. And once this connectivity is done, the connection to the AWS environment will be formed over the virtual LANs. And from there on, you will be able to communicate from your remote network to the AWS network without the involvement of internet. So that was a major difference between the DX and VPN. So I hope you have understood all the services and the features that you can use for your multi-VPC environments or even the hybrid connections. And let's meet in the next video then. Thank you.